Hello, this is Tony Hiller from visitech.ai. In this short video, I'm going to show you how to use Visitech to quickly analyze a difficult scientific problem. In this case, it is time of observation bias we will be analyzing, and I will explain it as we go along. This graph is from NOAA and shows how they believe time of observation bias affects temperature records. In order to compensate for it, they subtract about 0.1 degrees Fahrenheit from older temperatures and add about 0.3 degrees onto temperatures between 1990 and 2000. This is generally only done for stations in the United States because there isn't enough information for most of the other stations around the world. Now we're going to go to app.visitech.ai to get started. This is what the website looks like for subscribers. For this analysis, we're going to look at temperatures in Illinois, so I'm going to select Illinois from this menu. Now on the right side of the window, we have a map of all 36 United States Historical Climatology Network stations in Illinois. For this analysis, we're going to look at Champaign, Illinois specifically, and later Danville. I'm going to select Champaign from the drop-down menu. Now on the left side of the screen, we have a graph of the almost 45,000 daily maximum temperature records taken at Champaign, Illinois. By hovering the mouse over it, we can see that the hottest day in Champaign was July 14, 1954, when they reached 109 degrees. And on July 14, 1936, they were 108 degrees. We can see that Champaign had a lot of hot weather in the past, so let's take a more detailed look at that. Group by year and calculate the number of days greater than or equal to 90. Now on the left side of the screen, we have a graph of the number of 90-degree days per year at Champaign, Illinois. We can see that they had a lot of 90-degree days in 1913, in 1934, 1936, 1954, 1988, and most recently in 2012. Now we're going to issue a different command. Group by day of year and calculate average, highest, and lowest. Now we have a graph on the left side showing for each day of the year the record maximum temperature, the average maximum temperature, and the lowest maximum temperature. Where you see spikes on the top graph, that corresponds to record heat waves. Champaign's hottest September 30th was 99 degrees. Let's do a different analysis now. Group by day of year and calculate the percent probability of greater than or equal to 80 degrees. Group by day of year and calculate the percent probability of greater than or equal to 90 degrees. Group by day of year and calculate the percent probability of greater than or equal to 100 degrees. Group by day of year and calculate the percent probability of greater than or equal to 60 degrees. We can see that from late May through late October, Champaign has nearly 100% probability of being over 60 degrees. Champaign never has a high probability of being over 90 degrees, and they have a very low probability of being over 100 degrees. Now we're going to take a look at time of observation bias by comparing Champaign to nearby Danville. I'm also going to select Danville by holding down the Control key on the keyboard and selecting Danville. Now we have daily maximum temperatures for both Champaign and Danville in different colors. In order to analyze time of observation bias, I have to calculate the difference. Difference. Now the red line on the graph shows the daily difference in temperatures between Champaign and Danville. There's something odd going on here. You can see that between about 1919 and 1958, there was a much smaller difference in temperature between Champaign and Danville than there has been since 1958. It is unlikely that this is due to some sort of climatic change and much more likely due to instrumentation differences. I'm going to zoom in on this spiky period around March 1989. On March 12, 1989, there was 17 degrees difference in temperature between Danville and Champaign. On March 15, 1989, there was 23 degrees difference in temperature. And on March 18, 1989, Danville was 36 degrees warmer than Champaign. It doesn't make sense that stations located so close together would have such large temperature differences. And if we look at the graphs for Danville and Champaign, we can see exactly what's going on. There were 3 spikes in temperature that month. During the first spike, Danville had 2 warm days, but Champaign only had 1. During the second spike, Danville had 2 warm days, but Champaign only had 1. And the same thing happened on the third spike. This is a big red flag that there's a problem with the way the temperatures are being measured. And if we look at NOAA's station records for Danville, we can see exactly what the problem is. Beginning in 1958, they started recording their temperatures at 1700 hours, which is 5 o'clock in the afternoon, or near the peak temperature of the day. I made a simulated hourly temperature graph to show you what the problem is. If all observers reset their min-max thermometer right at midnight, we would have an accurate temperature record. But if you reset your thermometer right at 5 p.m., you've got a big problem. What happens then is that this 90-degree temperature gets recorded for both the first day and the second day. Suppose a cold front comes through at 7 p.m. and the second day is much cooler. But both days get recorded at 90 degrees because the thermometer was reset at 5 p.m. And that's exactly what's going wrong at Danville. They reset their thermometer at 5 p.m., so they're double counting warm days. A min-max thermometer operates by recording the minimum and maximum temperatures since the last time it was reset. So resetting the thermometer near the peak temperature of the day is a big problem. The average temperature at Danville during this period was 51 degrees, but at Champaign it was only 47 degrees. The difference in the recorded temperatures between Champaign and Danville isn't real. It's an artifact of the way the data was collected. So we've solved a difficult scientific problem in just a few minutes. And this is just one small example of the nearly boundless capabilities we provide for subscribers at visitech. We hope to see you there soon.